See, come here. Look at this.
Is that the Meteor, Prof?
Yes, you're correct. And the meteor is approaching quicker than I expected. Contact the authority as well as the others. Call them for an urgent meeting right now.
Sure, Prof. Right away.
Hello, Aus.
Hello, Prof.
There is a meteor about to crash the Earth. I need you and Adana to find the information of the meteor. The elements, the size, the speed, everything. Calculate the estimated days for it to enter the Earth's atmosphere and where will it crash. Now.
Noted, Prof.
Sebuah pulau yang terdapat berdekatan timur Malaysia dikenali sebagai Pulau LABSTER.
تعرفوا باسم جزيرة LABSTER؟
晴朗天空出现强烈白。
Hello, I'm Michelle reporting live approximately 10 kilometers away from the crash site. As we all know, 2 days ago on 9th May 2022, a meteor has struck the LABSTER Island. Behind me here, as you can see, the authority has built a gate preventing anyone from getting into the crash site. Standing here with me is Professor Iqbal, Head of Scientists and Researchers. Greetings, Professor. Could you explain to us more about this accident?
So as we know, the meteor have struck the LABSTER Island 2 days before. Luckily, there were no casualties or bad injuries happened to all the citizens. Thanks to the great cooperation between the authorities and the government as they managed to evacuate the islands before the meteor struck here. The impact of the meteor has caused a big crater, and the size of the crater is about 500 meters in diameter. Fortunately, the size of the meteor that striking here is small in size compared to others meteor that had struck our Earth before.
Wonderful, Professor. Other than that, can you share to us what will the next action will be taken by the researchers or from the government?
Regarding to that, it will be elaborated more by the mayor in the next press conference.
All right, thank you so much, Professor. Please stay tuned on the next press conference tonight. That's all from me. I'll pass back the report back to Ms. Christabel.
I, Sir Irsyad, Mayor of LABSTER Island, announce the total evacuation and lockdown of LABSTER Island until further notice. Next one, I want to introduce the team sent by the NSRA for the rehabilitation plan for the island. Alright. Their main mission is to perform proper analysis of the meteor sample, discovering its radioactive element and its half-life, then estimate the number of days until radioactive concentration reaches safe levels for the rehabilitation plans to be executed. Let's pray for the best for our team that will be handling this dangerous mission. With that, thank you.
Welcome, Prof.
Alright, this is everyone. Alright, I think everyone here knows why we are here today. So our mission is important for the sake of the LABSTER Islands. Our objective is to identify the element or radioactive that found in the meteorite, calculate the half-life of the radioisotopes, determine the safest date to reopen back the LABSTER Islands, and lastly, what method that can be used to justify the isotopes. Okay, for the problem statement. First, what is the radioisotope of the meteor? How long does it take for the isotopes to decay until the concentration reach safe level? To find that, we should determine the half-life of the isotopes. And lastly, what method can be used to justify the radioisotope?
Sir, for our mission in this situation, I suggest we collect sample nearby the crash site like the LABSTER lake. Evaporate the sample and use the pure radioisotope left and identify and weigh the initial mass of the radioisotope using mass spectrometry.
I agree with Firdaus, Prof. The data of the mass collected after 1 day will be used in the integrated rate law of the first order to calculate the rate constant.
A graph of concentration of isotope in PBB can then be plotted against time in days using the integrated rate law equation. We can finally identify the time taken for the mass to reach safe levels of 350 ppb through graph.
The rate constant value then we can use to determine the theoretical value of the radioactive half-life. Then we can record the mass of isotope for every 20 days using the mass spectrometry to determine the value of the radioisotope half-life.
Very good suggestion, everyone. So we need to start first now. Wear PPE when entering the crash site for sample collections to avoid radiation poisoning.
Prof, it is confirmed that the isotope is iridium-192 after constant measurement testing using mass spectrometry.
We're going to get a look at our main mission where the initial concentration on our LABSTER island is 5.2 molality. So right now, we want it to be 350 ppb where it is a safe concentration for all the residents to come back. So first thing we have to do is convert 5.2 molality into molarity. So right now, the formula for 5.2 molality is 5.2 mol over 1 kg of solvent, which is water. Then formula for molarity is mol over volume. So right now we have to find the volume where we can use the formula of density equals to mass over volume. Mass for iridium can be found by 5.2 mol times with its molar mass, which is 192.217 gram over mol. Then we get 999.528 gram. Then for volume iridium, we can use back the formula by dividing mass with its volume. So don't forget to change centimeter cube into meter cube, which is SI unit. Then we can fill it into the formula of molarity where 5.2 mol divided by total volume of solution, which is 1 total volume of water plus volume of iridium. Then we get 4.979 molarity. Then for our safe concentration, which is 350 ppb, the formula is 350 gram of iridium divided by 10 to the power of 9 gram of H2O times to the power of 10 to the power of 9. And then same formula for molarity where mol iridium divided by volume of H2O. Then we can just do like normal mathematics, 350 gram times with 1 mol iridium over 192.217 gram over mol, which is to find the molarity for iridium. And then volume of water, we can use 10 to the power of 9 gram of H2O times with 1 milliliter over 1 gram times with 1 liter over 10 to the power of 3 milliliter to get liter. And our final answer is 1.8208 times to the power of 10 negative 6 molarity. So this one is our initial concentration and this is our final concentration. So right now, the second thing that we have to do is to find how many days that it takes for iridium-192 to decay until safe concentration, which is 1.8208 times to the power of 10 negative 6 molarity. So to make it easier, make sure you plot a table where we assume the half-life of iridium is 20 days. And from the initial concentration, we divide it into 2 for each 20 days. Then from the equation, first order equation that we learned, we can find this from the T, but first thing we need is K. So how to find K? We plot the graph between ln concentration versus time. For ln concentration we can get by click the calculator, okay, and then after we plot the graph we can get the K value, which is from this graph the K value is 0.0347. So then substitute into the equation, first order law equation, ln 1.8208 times to the power of 10 negative 6, which is the concentration, final concentration, equals to negative K T plus ln A, the initial concentration. So then the we get 427.13 days, or it's actually 427 days. And the half-life, we can calculate by using the formula T half-life equals to ln T ln 2 over K, which is 19.9, or equivalent to 20 days. So the total of days for the LABSTER island to get the safe concentration is 427 days.
Wait, Prof. What should we do when the day arrives? What is our plan for the rehabilitation for the LABSTER island?
About that, I suggest to do reverse osmosis method. Reverse osmosis is a water purification process that uses semi-permeable membrane to filter out unwanted particles and large particles. This method is supported by the United States Environmental Protection Agency to remove radioactive contaminants such as iridium.
Noted, Prof.
Alright, Betty Michelle, now we need to report to our manager about our new finding.
Oh, Professor Iqbal, do you have any updates for now?
So we are here to report our new findings about the meteorite.
Oh, okay. Sit, have a seat.
Yesterday, the government officials, NSRA team, and I held a meeting discussing the findings of the research made. The radioactive element is found to be iridium contained in the meteorite, and its half-life is 20 days. It will take approximately 431 days for the radiation to reach safe levels of 350 parts per billion, or ppb. Thus, I announced the date for the reopening and restructure of LABSTER Island will be on 10th of November 2023. The country expresses gratitude for the flawless work of the NSRA team and everyone involved in achieving this result. With that, thank you.
So now let's have an interview with the head of science department, Professor Iqbal, and with the mayor of LABSTER Island, Sir Irsyad. So Professor, do you have any word to say about LABSTER Island these days?
Nothing much to say, but I just want to say that I'm really proud of my team because all of them have done a great job in this project. And for now, our team is doing the rehabilitation process to restructure back our LABSTER Island.
So Mayor, do you have any word to say?
Firstly, I again want to express my gratitude towards Professor Iqbal, the government, and the authority of LABSTER Island for their swift success in restructuring LABSTER Island since more than 1 year ago. I am sincerely glad that no lives were harmed during the process, and I want to say good luck to Iqbal and his team for the rehabilitation plan for our island. And yes, thank you Iqbal.
Thank you, Professor. Thank you, sir. And I think that is all for the news today, and have a good day.